So hello friends, today we are going to learn about an interesting topic, a topic from which all your mostly appliances work, electricity. Now first we will learn about electric current. Electric current is simply rate of flow of current, and current flows by the movement of free electrons. And let me show you a diagram of an atom. Atoms look like this. This is an bond of protons and neutrons, and the outside boundaries of valence electrons. Valence electrons are the outer electrons. Okay, and how to find electric current? The formula for that is I equals to Q upon T, in which I equals to current, Q equals to charge, but Q is the sign to represent charge, and Q equals to Coulomb. Coulomb is the unit of charge, and rate of flow of current, in which rate means by time. By time is the meaning that in which time, in that much of time, how much current flows. We can see it here, like time is upon, that's upon means by. Okay, and in the formula of current we represent time by seconds. Now let's study about electric circuit. Electric circuit. So what electric circuit means? It is the combinations of all the electric components, and the components mainly are wire, key. Another name of key is the switch that is used to open or close the circuit, and the appliance in this circuit we are using it like a bulb, and bulb is mostly used to represent mainly circuits, and this is a cell, and or to connect these all the components we use wire. Okay, now why are we studying electric circuit? We are studying it because the electric current which we are studying is the thing in which we apply in an electric circuit. Like in these wires the current flow, and it flows by the movement of free electrons. And let me tell you about conductors and insulators. Conductors are the materials which conduct electricity, and insulators are the materials which doesn't. And conductors are used for another term of heat. The materials which conduct heat are known as conductors, and which doesn't are known as insulators. Now conductors are the materials which have valence electrons. Okay, these valence electrons. Conductors are the materials which have these, and in insulators, insulator doesn't have valence electrons moving. Okay, and now let me tell you the conventional flow and flow of electrons. Let me make an electric circuit again. Okay, now electric conventional flow of current is from positive to negative, and the flow of electrons is from negative to positive. Okay, this is a very important question. It can be asked in the exams. Now let's just see some experiments done by scientists. Now let's study about some experiments and the inventions done by scientists. The first is when In Benjamin Franklin's kite experiment, Benjamin Franklin, this is a simple cartoon figure, he holded a kite in a thunderstorm, and the thread from which he was holding the kite was wet, so that the thread can conduct electricity. So when he wanted to prove that the lightning in which the lightning, wait a second, yes, lightning, I am talking about this type of lightning which come in thunderstorms, and he wanted to prove that this lightning is a form of electricity. So he held a kite in the thunderstorm, and when lightning occurred, he felt some current, in which a shock, in which he proved that lightning is a form of electricity. Now let's see an invention done by Thomas Alva Edison. Incandescent bulbs. Incandescent bulbs are the normal, the old bulbs that we used, and in some houses we use in this era also, and they were on the heating effect of current. We will learn about it later in this video. Just keep in mind that Thomas Alva Edison made incandescent bulbs. Now let's study about how many electrons are there in a charge. Let me just tell you in a simple way. One electron have minus 1.6 into 10 raised to minus 19, and to find out how many numbers of electrons are there in 1 coulomb, is that 1 coulomb upon divided by the coulomb in an electron. 1.6 into 10 raised to power minus 19. Now we will move upwards the 10 raised to power minus 19. So after that it will be 1 into 10 raised to 19, because minus is changed into plus when it moves forward, and in upon it will be 1.6. Now when it can be also written as 1 into 10 raised to 19 and 16 upon 10. Now it can be also written like this, and 10 would go upwards into 1, so it will be now, it will be 10 into 10 90 upon 1.6. Now we can also do one thing, that we can add 1 power of 10 into 10, so it will be like 100 into 10 raised to power 18 upon 1.6, 16. Now we will just do the calculations. So it will be, now we will just do the calculations, and I think I don't have to tell you that which is dividing by which. So I will just do the calculation, you can see it. And now the total answer will be the amount of electrons in 1 coulomb are 6.25 into 10 raised to power 18. That is your answer. So now we will study about electric circuits components. So the symbols of the components are, so these are some basics that you have to learn. You can just take a screenshot and learn them, so because these will be used in your questions. Okay, now let's study about electric potential or potential difference. So I have written everything about electric potential. Now I will explain it. Electric potential is measured in the unit by volts, and the symbol for it is V. And what electric potential means, let me explain you with an example. Like we have an beaker with the water filled with this much level, and we have a small container with a very low water containing, and we have a tube. So water will flow from this tube to this tube. Okay, so this is electric potential. And let me give you another example. And when they are equal, no current will flow in the case of electric circuit. Like this is a plane and we have a circular type thing. Now if it is in the slanting shape, it will move forward, and if the line is straight, so the circle doesn't move. And this case happens in same as in the electric circuits. So battery is, if you have seen that battery has written 6 volt, 2 volt, 1.5 volts. So what it means? It simply means the electric potential. Like on the negative terminal, it has 0 volts, and on the positive terminal it is 6 volts. So it creates a potential difference. Like this, it is 6 volts and this is 0 volts. So the current is flowing like this. So it proves that current needs potential difference to move. Now what it is written, electrons may move only when there is electric pressure along the conductor. It is the same thing that I tell you that, and electric pressure, don't confuse with it. It is the other name of potential difference or electric potential. Okay, now let's study about this only. Potential difference V equals to work done upon Q equals to charge, and the symbol for this is joule. Okay, now it will be used in many equations, so learn it. Now let's learn about resistance. Let me write it for you again. So resistance means the property of conductor that oppose current, and you have seen that when current flows from wire gets hot. The reason behind it is that the collision of electrons, and when a collision of something happen, friction is evolved and then product is heat. So that's why the reason that wire gets hot. And the formula for resistance is let me tell you that imagine that this is a wire, okay, and if we increase the area, cross sectional area, so its area will, the resistance will decrease, and if we increase its length, so the resistance will increase. Okay, so R is resistance is directly proportional to L upon A, and to remove the sign of proportionality we add a constant instead of proportionality sign. So the constant that we added is rho, which is the nature of material. Okay, like that at what temperature it is, the material is, and something like that. Now let's study about Ohm's law. So in Ohm's law, you don't have to learn anything much. So just learn that this is potential difference and this is current. So potential difference is directly proportional to current, and to remove the proportionality sign we have to add in constant, and in this case the constant is resistance. So like an example, if we have to find a resistance and we have given we have potential difference in current, so we will find it like the potential difference will go here and resistance will go here. So resistance equals to I upon V, V upon I. Now let's study the last point of the chapter, heating effect. So in heating effect you don't have to learn that much. W equals to work done, and work done is an energy, so energy can be written also as heat, so it is heat, and this is the formula of heating effect. So work done equals to charge into what potential difference, and from now we can write it like H equals to QV, and charge we can write it like IT, so we can write H equals to ITV, and now V can be written as IR by the Ohm's law, so we will write it like H equals to ITIV, and I is 2 times, so we can write it H equals to I square RT, and in this I is directly proportional to heat, I square, and our resistance is also proportional to it, and time is also directly proportional to it. So bye friends.